Let's bring Ben Campbell, Field CTO at Ververica, to the stage to show us a demo of Ververica's unified streaming data platform and Fluss in action together.
Well, hello everyone, and thank you for listening to me for the first time today. Some of you had to sit through my training for the last 2 days, but it's great to be back on stage here again. So let's take a very practical look at running Fluss on the Ververica platform today. Key thing to note here is that Fluss is about solving practical problems with streaming, from when you need to materialize a clickstream, not going to another data source. When you want to view your baskets in an e-commerce shop, having the data there and then in a queryable format. So, let's go into it first. First thing we need to do is build a cluster. Fluss, like any of the other things we have, is another Apache project where we must first deploy a cluster. On our dashboard here today, we're going to create one live. Now, this is running in real time because we want answers now. First, we're going to build our cluster, and then we're going to access it. We're running this video in actually one-to-one fashion because it became important because we realized that this thing happened as fast as we thought it did, so we don't want to slow it down for you so you can see what it really looks like. There's a full enterprise control plane here, so as you create this, you can then go through, see what's going on, observe everything in the platform, and then have full RBAC control over it. Most of these projects, when they first come out, are missing the enterprise features you need to be able to launch this in production. Not so with Fluss. We've gone through and added everything you need to take this into production today with no risk and full governance. This is then one-to-one integrated with VERA. So there's no kind of compromise here. Fluss can stand alone, but without a query engine to go with it, your data doesn't do much more than move. So let's connect this with VERA. The first thing we'll need to do is create a catalog. Because Fluss is a unification of tables and streams to the point where there's no distinction, you can now just create a catalog over the whole thing. There's no impedance mismatch with schemas anymore. You can do this through the lovely ClickOps window you can see today, but we all know that that's not what we want to do in production. The practicalities here are about being able to do it on a nice CI/CD pipeline or from code, or let's do it from SQL. When you're actually trying to build a columnar data pipeline for your true business outcomes, you don't want to have to sacrifice by having to go into a UI. Instead, you can deliver the value now. Have materialized views now. Make sure your users can see the data they need to make the decisions they want on your systems. Don't pay for a fast system without having data now. As you create tables and other views in Fluss, they appear immediately in front of you. And then we can go inside it, and we can start to see inside the catalog now. As we refresh it, you get to see inside Fluss. Fluss is logically organized into databases, and inside each database is a table. The table is either a change stream, or a materialized view, or both. As we look through this, you can start to see our clickstream example. Today, we're going to take an example of something like a Netflix-type streaming show, and we're going to derive some real-time insights from those streams of data coming from the front end. As with all these kind of analytics workloads, there is a lot of data coming through, and you can start to see them as we go through the columns which are available. The problem with dealing with this in a kind of classical streaming format is that it's a byte-oriented feed. There's no data attached to it until we add it afterwards. The days of schema on read was fine in 2012, but it's 13 years later and it feels a bit out of date these days. So now let's use a bit of that and construct some real data products. Most of us have heard the promise of the data mesh, but we're here to deliver it live. So right now, we're going to create a derive table on top of our existing raw pipeline so we can actually get the value that your data science team, your customer analytics team, or even some of your microservices might need so that the users can see updates as it happens without having to pay a crazy network cost when it comes to paying for every single thing along the way. If you have to deserialize data over and over again between your pipeline, if you have to pull columns you don't need, you're paying for things you don't want. So now let's have a look at what we can see. It's fun to build, but it's better to see. So running on a session cluster right now, we're just going to do a quick select into one of our Fluss tables. And this is kind of one of our feeds we've just designed. Immediately, it'll start materializing out on screen, and we can start running it to see the data feed through. You don't want to start developing pipelines without knowing they're going to be good. It's not enough to simply debug with a test passed, particularly with some of these things which are user-facing. You want to be able to look at the data, feel the data, and even graph the data with built-in visualizations to see what's going on. We all know clickstreams can be noisy, so we're going to have to clean that up a bit before we put it into production. So we're going to push it out to start with, but then we're going to have to do a bit more downstream. Pushing to production on the Ververica platform is seamless. We take the code we have, we declare any variables we want around parallelism, and then we deep validate it before it hits. The deep validation means that everything from networking to parallelism to available operators are unimpeachable on the point of deploy. You will never hit something into production with a dead pipeline anymore. This is one of those guarantees. Beyond that, we now need to join this data up. We want to enrich it from somewhere else. This is where the delta join comes in. A delta join is when we are effectively doing a partial lookup against a streaming source. Rather than having to materialize the full streaming source into Flink state, causing ballooning states with large joins, with Fluss and Paimon, you can do a delta join. Delta joins have been backported into earlier versions for onward support, but the key thing here is that we can do high-speed joins on streams of data without having to sacrifice the agility when it comes to rescaling things. The big gain here is that you can now act on more data than you previously could do without having to pay a cost up front. As it looks like a classic thing, but the latency is lower, you're not having to pay an extra cost in the state store, and you can have more different things going on. This can be on both sides of the join as well. There's no longer a need to have all of either side in state. And this clocks up pretty quick. As we start to stream from megabytes to gigabytes to terabytes, the ability not to have your RocksDB or streaming database balloon out of control is important. Even with tiered storage and disaggregated state, it's still expensive to have that. And this has other benefits down the line. Like, it's great to have checkpoints that run really, really quick and light. If your checkpoint is merely some more offsets into another stream, it means you can go faster with fewer stop the worlds, and even faster rescaling and restoring, because we have an external data source which is optimized for streaming and optimized for these kinds of joins, which drive all these modern analytical techniques you need. And this is a continuous pipeline, and it is for both batch and real time. This works in both bounded and unbounded sources, and by minimizing those checkpoints, you can get the results you need with VERA and Fluss today. This is coming live to our unified streaming data platform and allowing you to do things at any scale, with stream or batch. This makes us the architects of now. Most of the time when you're doing things for your customers, they don't want to pay for real time. They want to pay for now. When you press a button, you want it now.